Hey there. I am starting our first video here, 734. This is day one. And what I'm going to do is I'm going to quickly go through just the in-class work here. It might be a little fast, but your ability to just pause, rewind, listen again allows you to kind of control the way things go. If you have questions on anything as you go through, let me know. Of course, I'm human, so I'll make a mistake here or there. If you catch it, let me know, please. And we're going to give it a whirl here, and let's see how things work out. So first thing I'm going to do, I'm going to skip the intro paragraph because I know that you guys can read that for yourself. And what I'm going to do is get right into the work. This one is our key part, though, just so that we're thinking of this, is finding equations and inequalities. And equations means that we're going to have equal signs. Inequalities could be less than, greater than, less than and equal to, greater than or equal to. So that's what we're working on doing today, and that's what we're going to try to piece together. So today we have an airplane. It's at full capacity, carrying an unknown number of passengers and 7 crew members. What variable could you use to represent the unknown number of passengers? Well, in my mind, I would want to use P. P because P just could represent passengers. So I would write P, and I'd write passengers. And we've now picked our variable, P, but we've also defined it by saying what it is. It's the passengers. So by defining it, it makes it a whole lot easier for everybody, including yourself later on, to keep in mind what it is. So what we're going to do, write an expression, not an equation, so there's no equal sign in there or no inequality signs. Write an expression for the total number of people on the plane. An expression does not have that equal sign. And for example, x minus 3 is an expression. So if we go back up above, it says carrying an unknown number of passengers and 7 crew members. That would be my total number of people on the plane. An equation can be used to help you find the value of an unknown variable. Equations have expressions on both sides of an equal sign. For example, 9 parentheses 2x plus 7 parentheses equals 20 or 228. That's an equation. Why? Because what you see is you see this expression, but then you also see that expression. It's on both sides. The plane was designed to hold 241 people. Write an equation that equates the total number of people to your expression in part A from above. So let's go grab that. That was P plus 7. So there's my P plus 7. Then we need to have that equal sign. What's the other expression? The other expression is the 241 people. There's an expression, or I'm sorry, there's an equation that represents the people that we have there. Thinking about your idea of inverse operations, let's take a second just to review inverse operations. We did talk about it. I'm sure it seems like forever ago, and for many of us, we probably forgot what some of that looks like. But an inverse operation of addition is subtraction. The inverse operation of subtraction is addition. The inverse operation of multiplication is division. The inverse multiplication of division is multiplication. So, determine what the value of your variable that your variable needs to be in order to solve your equation. That is, how many passengers can fly in the plane, right? A complete sentence. So P plus 7 equals 241. P plus 7 equals 241. I should take a second. I should take a second to note that, what in the world? That you could write this as 241 equals P plus 7. It is the same thing. Whoa, that's, what happened here? There we go. I must have hit the thing on the right side there. So that this is the same and that you can do it both ways, okay? So P plus 7 equals 241. If we think about inverse operations, the key is that plus means that I'm going to have to subtract, right? So you could think about it like this: 241 minus 7, right? That would be 234. Now, why in the world would we do that? Well, think about how that 234 would go right here, right? If we had that variable and we said it was 234, that would mean that 234 plus 7 equals 241. Oh yeah, that would equal, wouldn't it? And so what we have is this 234 is what we call a solution. So to write a complete sentence on there, we could say there are 234 passengers on the plane. Just following our directions there. Whenever it flies, the airplane's not always at full capacity. Using what you wrote in Part B as a start, write an inequality to relate the total number of people to the capacity of the plane. In the inequality, use the mathematical symbol for less than or equal to. So we have the symbol right there. And there's our less than or equal to, right? So if we think about all the people that are on the plane, the most that we can have was 241. So all of our passengers plus our 7 crew members, right, has to be less than or equal to 241. We can't exceed 241. We run out of seats. We could have 0 passengers on there, right? We could have 0 passengers, but we still have 7 crew members on there. And that's definitely under the 241 total people that it can hold. Now, that would be a pretty ridiculous flight, but it would work. And that goes into E. What values of P will make the inequality you wrote in Part D true? That is, what are the solutions to the inequality? Well, of course, the solutions are all the possible people, the amount of people that we could have. And if we take a look, like I just said, we could have 0, couldn't we? Could have 0. Could we have 300? Well, absolutely not. 300 plus 7 is 307, right? And if we had 307, that's not less than or equal to 241. Well, we did the hard work up above, didn't we? The work up here said that's the most, that's if we were at full capacity, 234. So what values for P could we have? 0 to 234 passengers. According to the attendance office, Lakeside Middle School has, 57 fewer students than Xavier Middle School. You want to determine the number of students that will attend Xavier Middle School. When you use a variable to represent an unknown, you will need to define the variable using a let statement to communicate what your variable represents. For example, in problem 112, you could have said, let P represent the number of passengers. Write an algebraic expression for the number of students at Lakeside Middle School. Make sure you define the variable that you choose. So we're doing only an expression. An expression that we could do would be x minus, not 7, that's from the previous problem, 57. And what does that mean? Lakeside has 57 fewer students than Xavier. Now, it's a really tricky thing because what it means is without defining our x, it's really hard to understand. So what we'll do is we'll just say let x represent that's not annoying. Represent the number I do not like that view on the far right side. I hit it with my hand. Let the number of students at Xavier Middle School. What in the world? I'm trying to trying to avoid that part on the right, but I keep bumping it with my finger. So x minus 57, if x is the number of students at Xavier, I'm just going a little bit further there. Xavier, the Lakeside Middle School has 57 fewer students than Xavier. That means Xavier has more than. So if we say that's Xavier, Xavier minus the 57 is what Lakeside would be. Very often, kids will do something like x plus 57 because they think that Xavier, it's like Xavier plus the 57 is Lakeside. It's hard to explain or describe, but a lot of students will flip those around and do a plus on there. But if you define X to be Xavier Middle School, that will help. The attendance office says there are 403 students at Lakeside Middle School. Use the expression you wrote in Part A and write an equation for the number of students at Lakeside Middle School. So we'll go back to what we had here before. We had the X minus 57. And if it's an equation, we will say it's equal to, and what is it going to be equal to? The 403 students at Lakeside Middle School. Now, let's find out, well, we've created that equation. My guess is that in C, we've got to figure out how many students are at Xavier, right? How many students are at Xavier Middle School? Well, at Xavier Middle School, we are going to have to figure out what that X is, right? So we could use those inverse operations that we just talked about earlier, and we could say 403 plus 57 to give us a total of 460 total students. So we explain how we use those inverse. We used addition to undo the subtraction. Use the equation to show how you use that 550 is not the number of students who are at Xavier Middle School. Test two other values to make that equation true. How many solutions are there to the equation that you wrote in Part B? So what they're saying is that x minus 57, which equals 403, right? What they're doing is show that 550 does not work. So what we could do is we could say 550 minus 57, right? What does that equal? Well, 550 minus 57, excuse me, is 493. Is that what we have? No, of course not. So 550 does not work, right? 550 will not work. And you guys should try two other values that would not work too. Just show that those two other values would work. For example, you could try 500. You could try 1,000. You could try 1,000,000. It's up to you. I'd choose nice numbers if I were you. Ellie is building a dollhouse. She has boards that are two different lengths. A long board is 17 inches longer than the short board. Draw a picture showing how the short and long boards are related. The length of the board is 50 inches. So if we draw a picture showing how the short and long boards are related, right? Here they are. The length of the long board is 50 inches. The length of the short board is unknown. There we go. Now we're going to write an equation that shows how the length of the long board is related to the length of the short board. An equation to show, remember to define your variable first. Well, there's our S, right? And what we could say is there's one part we didn't list, but we do know. From here to here, right? From there to there, it is, whoops, did we have that? We did have that. I'm sorry. I felt like we were missing something. We were told earlier that there's 17 inches between there. So this is 17. There, that helps us out a little bit. So S plus 17 has to equal my S, the short board, plus 17 inches has to equal the big board of 50. Oops. Defining our variable, S is the length of the short board. Ellie estimates the length of the shortboard between 30 and 40 inches. Test at least 3 values in this range in your equation. Where any of the values you tested a solution, how do you know? So what we have, though, we could just check 30. So 30 or 40, test 3 values. What we could do is just pick one, right? So we could just say 35. Something like that. 35 could be our first pick. Our equation, remember, is 50 equals S plus 17. Right? So what we would do is test that in there. 50 equals 35 plus 17. Well, I shouldn't say that they're equals because I don't know for sure. I should check it. 35 and 17. 2, 1, 57, that's not going to work, right? So we are asked to at least test 3 values in that 30 to 40. So it looks like that's too big, right? 52 is too big. Looks like I should try, since 52 is just 2 bigger than that, then what I should do is probably choose a value that's 2 times smaller than that. So I would choose 33 right now, right? 35 plus, I'm sorry, not 35. 35 was for the previous one, wasn't it? 33 plus 17 equals 50. And that's the happy, right? Happy times. What's the length of the shortboard? Is there more than one answer? Well, we actually just found it, didn't we? It's 33. Is there more than one possible answer? And the answer to that is no. There is only one solution, we call that. Solution, one answer that would work. Jeffrey's comparing the number of pages in his science book to his math book. Jeffrey does not have science class today, so he left his book at home. The number of pages in his science textbook is unknown. Jeffrey also has a paperback science lab manual. Each lab activity is 2 pages long, and there are 25 lab activities. Define a variable and write an expression for the total number of pages of science materials, including the hardbook textbook. So what we could do is we could just say S is the length, well, I should say the number of pages, I guess, but the length of the science hard book, right? And then what we could say is we could say, since we found out that the lab manual, right, the lab manual, each lab activity is 2 pages long and there's 25 lab activities. So what we know is that this means that there's 50 pages in the lab manual, right? So we could say S plus 50. S plus 50 would be the equation that I would use for that one. By looking at his math book, Jeffrey thinks the total number of pages in the science materials is more than, there's that inequality of 425 pages of his math book. Write an inequality, that means that we're going to need that symbol, to relate the number of science pages to the number of math pages. In the inequality, use the mathematical symbol for greater than. So what we'd say is we'd say S plus 50, the total number of science pages, is greater than the pages in his math book, which is 425, just in his estimation. Those are all the core problems. I encourage you to look at all of these right here because the math notes are really helpful, and it talks about how to find those equations, or talking about those, and how to find those inequalities. We haven't talked a ton of it yet, but we're really going to get far into this stuff here at some point. So if you have any questions, let me know.